if x, y, and z are positive numbers, is z between x and y? So they're asking, is this true? Or technically, I guess I can ask also, or this. They don't necessarily say x is less than y, so is either of these true? All we know is they are all positive numbers, so let's look at the statements. 2z is between x and y, and here they do tell you x is less than y, so let's on the number line, because I really have to visualize this stuff. It's hard for me to just think about these number line questions in my head. So here I don't know anything about z. I know something about 2z though. 2z is between x and y. So if I want to think about what does this mean for z, well, the easiest way to do this, I think, is to give myself a pretty wide range for what x and y can be. So I don't know, say 3 to 10 or something, because then I can say, okay, so what can I have? Can I come up with possibilities both where z is outside of this range and where z is inside this range? And first, all I got to do is make sure 2z is within the range. So one easy example I can come up with was, say, z is 2. So 2z is 4, which is within the range. So if I want to start organizing this information in a table, I need an x, I need a z, I need a 2z, which I need to make sure is within this range, and then I need a y. And so we said x is 3, y is 10, z is 2, 2z is 4. Then I got to answer my question. Is z between x and y? And so here we have a no, because 2 is not between 3 and 10. So now can I get another example where z is within the range? So I can say, well, what about if z is equal to 4? So in that case, I'll keep everything else the same. X is y, x is 3, y is 10, z is 4, so 2z is 8. So I just got to make sure 8 is between 3 and 10, which it is. And now I have a case where z is between 3 and 10. So this guy here is insufficient. Statement 2. So now they say z is between 2x and 2y. So if I want to sort of make my statements a bit more comparable, because here I was able to tackle this first statement with everything in terms of x and y. So if I want to do the same thing here, just to keep my brain from having to switch gears, I can divide everything here by 2, and then I get x. So 1/2 of z is between x and y. So now here I can sort of approach this in a similar way to the first statement. So let's even use the same values for x and y. So let's say x is equal to 3, y is equal to 10. And what do we know? We know 1/2 of z is within this range. So in this case, z has got to be over here somewhere. So let's say one example I can think of is z is equal to 12. So in this case, if we make a similar chart like we did before, we'll have, let's divide our two statements. So here we'll have, we need an x, we need a z, we need a 1/2 z this time, and then we need our y, and x and y are 3 and 10. So here z is equal to 12, 1/2 z is equal to 6. So 1/2 z is what has to be within our range of 3 and 10. It is. So then we got to answer a question: is z between 3 and 10, and it is not. So now can I come up with an example where it is within the range? And it looks like if I make z equal to 8, that should work, because so keep x as 3, y is 10. Let's say z is 8, 1/2 z is 4, and so 4 is still within the range. It's still between 3 and 10. And now my z is also within the range, so I have a yes here. So that is enough to prove this guy insufficient. So now let's look at them together. And the good thing about looking at them together is I can now try and do some algebra with my inequalities here. And it looks like if I just add my two statements together, I get this inequality. 3x is less than 3z, which is less than 3y. And so then I can divide all of these guys by 3, and that just gives me x is less than z, which is less than y. Or z is between x and y. So together, these statements are sufficient.